Welcome to this session. In this session, we discuss how to change numbers from base 10 to any other new base. So we start by discussing how to change from binary form into binary form. That's to mean how to change a number from base 10 to base 2. So the trick we use, is to use the division algorithm The trick we use is to use division algorithm repeatedly until we obtain a quotient that is 0. So that is the trick that we use. I remember division algorithm means given two integers, A and B, such that B is non-zero and A is greater than B, then there exists two other integers Q and R, quotient and remainder respectively, such that this larger integer A can be written as A equals to B Q, then plus the remainder R, where this remainder R is strictly less than B, and it can be 0. So this is what we call the division algorithm. So what we do, or to convert from base 10 to base 2, we say repeat division by 2, which is the new base, noting the remainders at each stage, then continue dividing until a final 0 quotient is obtained. Then once we have obtained a 0 quotient, then write all the remainders in the reverse. This is very key. In the reverse order So reverse order means from the last one to the starting one. From bottom to top. So this step 1, this step 2, and then this step 3. Similarly, for the division algorithm, you do it repeatedly, and to the point you get the quotient 0, then you also rewrite the numbers, the remainders in the reverse process. So let's see an example. Example. Change 245, which is a number to base 10, to binary number. Remember, sometimes we can write 245 and then put a subscript 10, or we can write 245 and then put in brackets and then write 10 here. All of them will be used to mean the same thing. So I'll demonstrate all the two processes we have said, either doing it, dividing repeatedly by 2, and then noting the remainders, or using division algorithm to get the remainders. So solution. So method 1. Division algorithm. So this one, so we write, so you see we have the base is 2, and then the number is 245. So this, what we said, we have A equals to B Q plus R, then our A becomes 245, B will be 2. So you have now to start the question, to getting the quotients and the remainders. So when you write 245, can be written as 2 times 122 and then plus 1. So this is our first quotient. Now the division algorithm works that now once you have gotten this expression, then your quotient becomes now the new number, and then divided, the divisor remains to be 2. So you bring this 122 here, and 122, the divisor remains to be 2. So 122 divides, 2 divides 122, 61 times, and then the remainder is 0. But remember, you don't stop here because the remainder is 0. The thing is that you stop when the quotient is 0. And remember, the quotient are these numbers, these numbers in this column, and then these are remainders. This is the divisor 2, base 2. So then you bring this 61 at this point, and then divisor remains to be 2, and then 2 divides 61 30 times, and then the remainder is 1. Then bring this 30 at this point, and then divisor remains to be 2, and then 2 divides 30 15 number of times, and then the remainder is 0. You don't stop here. Remember, we only stop when the quotient, this column here, is 0. So still bring 15 here, and then divisor remains to be 2. 2 divides 15 7 times, and then the remainder is 1. And then bring this 7 here, then divisor remains to be 2. 2 divides 7 3 times, the remainder is 1. And then bring this 3 here, and then the divisor remains to be 2. 2 divides 3 1 time, and then the remainder is 1. Bring this quotient, which is 1, at this point here. Throughout this process, the divisor is 2. So to get 1, so 2 divides 1 0 times, and then the remainder is 1. So that 1 2 times 0 is 0 plus 1, you get still 1. Now, because now at this point is when our quotient is 0, then we stop. This quotient is now 0, then we have to stop. Now, once we stop, after getting the 0 quotient, then these remainders, you write them in the reverse process. These remainders, you write them in the reverse process. So the reverse process means that you start from bottom here. So we have 1, 2, 3, 4, 5. So 1, 1, 2, 3, 4. And then 0, 1, 0, 1. So this number to base 2 is the same number as the original number, 245 to base 10. So the answer is 1, 1, 1, 1, 0, 1, 0, 1 to base 2. Or you can just write it as 1, 1, 1, 1, 0, 1, 0, 1 to base 2 is the same as 245 to base 10. So this is how we find the answer. Or method 2, you can give your division in this form. So you write this line, and then, so this is the number 245, and then you put here 2. So 2 divides 245, 122, and then the remainder, so just write here remainders. Remainder is 1. And then 2 divides 122, 61 times, remainder is 0. 2 divides 61, 30 times, the remainder is 1. 2 divides 30, 15 number of times, the remainder is 0. 2 divides 15, 7 times, the remainder is 1. 2 divides 7, 3 times, the remainder is 1. And then 2 divides 3, 1 times, the remainder is 1. And then 2 divides 1, 0 times, the remainder is 1. Now, once we have a 0 remainder, then that's when we stop. So because we have 0 quotient, this is a quotient, then stop, and then you say 1, 2, 3, 4, 1, 2, 3, 4, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1 to base 2 is the same as 245. So that is how we do that problem. Example 2. Problem 2. Find the binary expansion of 241 to base 10. So we do the same process. So solution, I'll use division algorithm. So the number is 241. The divisor is 2 because the base is now 2. And then, so we have to use A equals to BQ plus R. B will be 2 throughout, and then so Q and R will be what will be changing. So 241, 2 divides it 120 times, the remainder is 1. Then you bring this 120 here, and then divisor remains to be 2. 2 divides 120, 60 times, and then the remainder is 0. Bring this 60 here. 2 divides 60, 30 number of times, and then the remainder is 0. Bring 30 here. 2 divides 30, 15 number of times, the remainder is 0. And then bring 15 here. Divisor remains to be 2. 2 divides 15, 7 times, the remainder is 1. And then bring 7 here. 2 divides 7, 3 times, the remainder is 1. Then bring 3 here. 2 divides 3 1 times, and then the remainder is 1. Then bring this one here. 2 divides 1 0 times, the remainder is 1. Now immediately you get a 0 quotient, you stop. So this is 0 quotient, so stop. And then once you stop, you write these remainders in the reverse process. So the remainders are written in the reverse process from bottom up. So this is a bottom up economy. So we have 1, 1, 1, 1, 0, 0, 0, 1 to base 2 is the same as 241 to base 10. So this is the solution to that given problem. In the next session, we discuss how to convert a binary number into octal number. Thank you.